get into the new stuff. We went over the in-class assignment, we went over the homework. Let me start by mentioning this. Hopefully everybody saw this email about the supplemental instruction starting this week. I think is it this week? Yeah. So Mondays from, what does that say, 2 to 3, Wednesdays from 2 to 3, you can drop into, what is this, FCN, so the north side of this building, first floor, 127. I'm sure that's gonna be an easy room to find. But there's where it's taking place. Thursdays from 3:15 to 4:15. Are any of these Zoom? Oh, right there. Okay, Zoom is on Tuesdays from 11 to 12, Zoom. And there's the Zoom link. So you have 1, 2, 3, 4 different options to get some extra supplemental instruction. Does everybody know? Is there anybody who doesn't know what supplemental instruction is? It's a student, I think a student who had this class years ago and got an A probably or something like that, but I don't think she's had me. So, but she has my syllabus, so she knows what order we're going in, which is very different than the other class. So that's why that's important that she knows what's going on. So you have supplemental instruction. Next, I also posted an announcement about tutoring. What did I put? I just put a link, that's it. I just put a link because they've only got 1 tutor so far for this class, and they're about to get a 2nd tutor. So hit the link and you'll be able to get more information about the tutoring. That's free. Walk in, you can schedule it. There's even a schedule right there where you can do it virtually, schedule it. And I don't know if they offer Zoom tutoring or not, but I would imagine if they don't right now, they will before the end of the semester, I think. I don't know. Did they offer Zoom tutoring last year? Anybody know? Did anybody go to tutoring? There was no Zoom. What about with the SI, the supplemental instruction? Was there a Zoom for that?
Yeah. Well, she's talking about that side.
Oh, you are talking about SI. What about the tutoring though? Was there Zoom with the tutoring? Anybody? No? So you got a lot of help between and you know, the first quiz is your easiest quiz. Your only enemy is going to be time. So after the first quiz, if you feel like your grade's not where it should be, that's when you guys start hitting these things on a regular basis.
Professor, those 2 questions you're gonna add that are like half or 0.5 points, are they solving, like the ones for previous semesters, or are they conceptual?
You're talking about the assessment question?
Mm-hmm.
You're worried about the assessment question, really?
Yeah, because like these little points.
I have not
especially
read it, so I don't know exactly what they're about. I read one of them that won't be on this first quiz, and it was basically about you. Does the student remember how to either find or calculate the mean? The mean.
Just like yes or no.
You know, it's simple stuff from 301.
Because the first quiz is a very short amount of points, so like a full point is a lot actually.
I think I'm already at like over 10 points. I think we're gonna be at 16 or 20 points, so it's not, half a point's not gonna be a big deal.
Oh, I thought we're at like, I thought it's 10 points. Didn't you have it in school? It's like, it's not 20.
10%.
Yeah, it's 10%.
10% of your grade, yeah. Oh, I thought you meant the amount of points on the quiz itself.
Yeah, I meant that actually.
Yeah, so if there's 16 points, a half a point's nothing.
Oh, 16 points, but 10% of our grade. Okay.
Yeah, 16 points is like the total amount. I think I'm guessing that's where we're gonna end up. I think we're gonna end up more than 16 points. I think, because I think there's more problems on this than I already have planned in my head. All right, so now let's get to week 3 instructions. Oh, hey, here's week 3. Let me make it bigger. We have 1 document for homework, and when is our homework due?
Never.
Was that Evan?
No.
Who was it? Never, ever is it due. Between this week and the quiz, it's about preparing for the quiz. All right? Does everybody remember what's allowed on the quiz? Everything posted on Canvas. And then a book. And your notes, as long as you made them digital, so that they're on your computer, not paper notes. Nothing paper but the quiz. All right. Here's the materials for this week, slides and everything. A reminder about the quiz, Tuesday on the 24th, 2 p.m. You'll walk in, there'll be a seating chart up on the screen so you can figure out. The seating chart is in the rows, like right in front of you. So on the far right will be a row that stands for the first row. All the way to the left is the back row. That's how you look at it. Here's the homework that's not due. There's only 3 problems here. Page 297 are two of the problems, and page 301 is the third one. It says, show your detailed work solving manually, include the Excel function equation to find Z. I'm literally telling you to find the Excel function equation to find Z. But if this is a quiz, it's gonna say, include the Excel function equation to find Z or T. I'm not giving it away as to which one you gotta find. You gotta figure that out by reading the question. All right, now there's the three homeworks. Let's see, the second one's solving it manually, the third one's solving it manually, giving me that Excel equation. They're all three the same. We will on Thursday go over these, and we'll go over the answers real quick on Thursday so that it helps prepare. Now I want you to start being able to recognize this week's work, which is confidence intervals with proportions. Remember, the first one was confidence intervals with a mean and the population standard deviation, which meant we had to use Z. Last week was confidence interval for the mean, but we had the sample standard deviation, so we had to use T. This week is confidence intervals for proportion, which there is no standard deviation, so we have to use Z. The same Z calculation we used in week 1 is the exact same one we're using in this week, except I'm adding one to it, which is norm.s.inv, so you have options for finding Z now. You can use either one of them, which we'll talk about both of them in a minute. Here's an example though of a proportion question. Right away you should say, hey, it's asking for confidence interval, and there's no standard deviation. That's one way you know for sure it's a proportion. It says, let me make it bigger. How do you know it's a proportion? Because it's asking for a confidence interval and there's no standard deviation in it. So, matter of fact, most of quiz 1 is asking for confidence intervals. That's all we've been learning in these first 3 weeks is confidence intervals, confidence intervals. So, I'm preparing you for the final exam. Because we won't have confidence intervals after this week. After we get done with the quiz, there's no more confidence intervals until the final exam. And when you get to the final exam, there's probably going to be 1 or maybe 2 at the most confidence interval questions. So you got to be able to, how many weeks is that? 12 weeks from now, recognize what kind of confidence interval question you're reading so you know which formula to use. You know on this first quiz, you're going to be using all 3 of the formulas. It's just a matter of which one goes where. By the final exam, it's going to be a little tougher because 12 weeks have gone by before you even thought about confidence intervals. So here's an example of how to recognize proportion right here. Assume a sample proportion equals 6.60. Now that could say 0.60 or it could say 60%. That means the exact same thing. Don't get fooled if it says 60% words even. SIXTY, 60%. Or the number 60 with the percent symbol, but in this case 0.60. And the sample size of 50. Construct a 95% confidence interval manually using Excel to find the T or Z. There you go. Okay, mention confidence intervals. So I gotta figure out which formula to use. There's 3 of them. Hey, there's no standard deviation. Boom, proportion. Here is the proportion formula right here. Equals the given proportion. Sometimes you have to calculate the given proportion. I'll jump into one of those right now. You ready? Oh, I almost forgot. This is a word you gotta know. Can I spell this right? Where is it? S-U-C-C-E, there's 2 S's? Yeah. Don't let the word successes in statistics mean the same thing it means in the real world. In the real world, success is like, oh, that's the right answer, or that's the best thing that could happen. That's not what it means in statistics. Success is whatever it is we're measuring. It could be something not working. Could be what we're measuring. Whatever it says we're measuring is called the success. So how many successes did we have? Now the reason I'm bringing this up to you right now is because this manual equation, that first number proportion that's there, and there, 3 different places, sometimes you have to calculate it. It's not going to be given to you as 0.60 or 60%. It's going to be given to you as numbers like this. Now pretend this is the final exam. You don't even know what you're looking at this moment. If you're reading it, all of a sudden you say, oh, construct a 90% confidence interval. Boom. That's week 1, week 2, or week 3. Okay, do I have a population standard deviation? Do I have a sample standard deviation or no standard deviation? Because I know it's one of these 3 because the word confidence interval is there. It says a sample of 400, a company finds that there's 20 successes. Manually construct a 90% confidence interval using Excel to find Z or T. Okay, I now know this is a proportion. No standard deviation in that sentence at all. So now I know it's this formula, but I don't see the proportion. It doesn't jump right at me. It doesn't say 60% or 0.60. Here it is. Sample size of 400. And then it says there were 20 successes. So you're going to take 20 over 400. There's your proportion. However many successes over the sample size, divided by the sample size, is your proportion if it's not given to you. However many successes divided by the sample size is the proportion if it's not being given to you. Look at a third one. According to a survey, 44% of adults admit to keeping money secret from their partner. Suppose the survey was based on 1,000 respondents, manually construct 98% confidence interval using Excel to find Z or T. Okay, in this case, it says confidence interval, so you know it's from weeks 1, 2, or 3. There's no standard deviation, so now you know it's proportion, you know you're using the proportion formula. And what's the proportion being given to you? You don't even have to calculate it. It's given to you as 44%. What is 6? But I want you to be careful. Because maybe this question is a multiple choice question. The question would say, what is the success being measured? What's the success being measured? What is considered the success that was measured in this proportion? 44%. The 44% is the given proportion. But what's the success? How about this? What if I ask you, I'm going to change that question. How about this? You ready? How many successes were there?
44.
No, 44%. 440. Because it's 44% of 1,000 sample size. If we were not given that 44%, it would say there were 400 adults admitting to keeping money from secrets from their partner, and the sample size was 1,000. You'd have to take 440 divided by 1,000 to get the 44%. And I want to make sure you realize, you know, the question could say, hey, what was the number of successes in this problem? And you got to take 44% of 1,000 to work it backwards. Oh, there must have been 440 successes. Because 440 divided by 1,000 is how the 44% came about. Okay, now that we know that, let's do a full problem. Let me go back to the PowerPoint here. Confidence interval for population proportion. Forget those symbols. I'm using words. There's the formula. Write down the slide number 26. So let's see, the first week was the slide 10 was the formula, the second week was slide something else, and the third week was slide 26 is the formula. There's the 3 main formulas until we get to Thursday, because we got another formula coming up Thursday that's really important to find the optimal number of your sample size, the optimal number, which is Thursday's lecture. But today, I always put the formula in words, so that I want to put it in words. The proportion, matter of fact, we can call that the given proportion, the proportion plus and minus the Z, which we got to get the Excel equation to find our Z, times, here's the tough part. That square root is over this whole thing. I want everybody to hear that again. I can't tell you no matter how much I say this right now, and we're recording this, and someone's going to watch it. Someone's going to put that square root over the numerator only or the denominator only. That square root is over the whole thing for a proportion. I know the first 2 weeks the square root was just over the sample size, but not for proportions. It's over the whole thing. Proportion times 1 minus the proportion divided by the sample size, then square root. Matter of fact, I put the order of operations here. This is how badly I want you to have success on this part of the quiz. The order of operations is, number 1, subtract in the parentheses 1 minus the proportion. Number 2, multiply whatever you just got, 1 minus the proportion times the other proportion. Number 3, divide. Now divide that by the sample size. Number 4, now use square root. Number 5, multiply times Z. Number 6, add and subtract. There's the order of operations. You are going to be successful with these proportions if you follow that. This is the one that has the most math errors, and it's that whole darn part in parentheses here is where it happens. Right? You cannot do this division before, you cannot do this multiplication before you do that subtraction. You can't do that division for the subtraction. You can't do that square root before that first subtraction. You gotta do those parentheses first. All right, let's do an example. We're literally plugging it in. We're gonna take it all, get the whole setup. We're not gonna take it all the way solving it, but we're gonna get the whole setup. Here it is. Random sample of 100 people shows that 25 are left-handed. Form a 95% confidence interval for the true proportion of left-handers. What's the successes we measured? What are the successes we measured? In words, not how many, in words. What did we measure and we're calling it a success?
25?
No, not how many. 25 is correct. On how many, I'm asking you what is the success we're measuring in words? Left-handed. We're measuring left-handed people. That's the success. That's what the word means, success, is whatever's being measured. And don't let the word success mean something positive, like in real life. Not at all. It's just whatever's being measured. In this case, it's left-handed people. So the success is left-handed people. How many? 25. What's our proportion? How do I find my initial proportion to get this problem started? There it is. 25 over 100 is going to equal my proportion, which happens to be 0.25. Everybody with me? There's three of the numbers. Three of the numbers. There it is. And now all I need to know is my sample size, which is how many? There it is, 100. And my z. Now, which formula should I use? Now, this is our time to learn the new formula. Let me bring this up. Here we go. Is it time to go to the free food? Oh no, we only got 16 minutes. Oh, man, how are we passing out free food? I would have skipped class if I were you. For the free food in the courtyard. If they were giving out t-shirts, I would have never been.
No, they're just giving out. If you get them, yeah, yes.
You have to spend something and possibly get a t-shirt?
No,
Oh.
or a cash.
Where am I at? Okay, here we go. NIMV means you would put in the confidence plus half the significance, and then you'd put a 0 and a 1 for the other two numbers. This is what we used in week 1. But I want to show you, here is norm SIMV, which we didn't learn in week 1, we're learning now. And this one, you only got to put the confidence, where is it at? Right here. Plus half the significance. You don't have to, you're just dropping off the 0 and 1. There's the difference. The bad news is you still got to use the confidence plus half the significance, which is the tough part for a lot of people. But there's the formula. So I want to use the new one. So here we go. I'm solving this problem. Oh, let me get the problem back here. I'm solving this problem just like it's a quiz problem here. Find the confidence. Here we go. I know it's 0.25. I'm going to do my formula here. Someone get the calculator out, or not calculator, Excel out, and enter this in. Norm dot S dot INV, parentheses. Help me out here. Look at this problem. What should be the number right here? 0.975. Very good. All right. Because 95% confidence means 5% significance. Half of 5% is 2.5%. Added to the 95 makes 97.5% confident, or what we're putting in for the first number. Excuse me.
Oh, we could use either or. This was
Yeah, either one of those two, either one. But they both got to have confidence plus half significance for the first number. So you're not really, it's going to be hard either way. Because you got to remember to do this for Z, but not for T. That's what's weird. So now we have our number. Somebody entered that in and got what?
1.96.
1 point, come on. What's
Zero.
it? 9.
60.
60? 60?
If you
Is he right? Is that true? 60? They never turn out like that. Seriously? 1.96. Now we got this. Here we go. I'm ready to do the setup. Are we ready? This is manual, so I don't have to put the equal sign in front, but I'm used to it, so I'm going to do it. 0.25 plus and minus 1.96, big parenthesis. Watch what I'm doing so I don't forget. Giant square root symbol right away, so I want to make sure I remember it's over both of them. Now here's the top, 0.25. I'm putting the asterisk times 1 minus 0.25. For manual, you don't have to have asterisk, you have to have that asterisk for Excel though. Over the sample size, which is 50 or 100? 100. Parentheses. There's the setup right there. 0.25 plus and minus 1.96. Parentheses, square root this whole thing. 0.25 times 1 minus 0.25 in parentheses. Over 100. Square rooted the whole thing. Now, if I were solving this, gotta give me two calculations. I would subtract parentheses. 1 minus 0.25 is 0.75. Multiply that 0.75 times 0.25 to get whatever you would get. Whatever that is. 0.18, I don't know. Then divide it by 100, whatever that is. Now we're at 0.0018 or whatever it is. Then square root it. Now we just made some bigger number, 0.16, who knows. Now multiply it times 1.96. Now take that result, add and subtract it to 0.25. And we found our upper and lower limits, which happen to be for 0.25 plus or minus 1.96 times that whole thing in the parentheses is 0.0433 after we square root it. So our upper limit is 0.3349 above 25%, 33.5%. And our lower limit, 16.51. I'm going to answer your question in just a second. Hang on, here we go. Well, here's our proportion, 25%. Our upper limit is up here at, what was the confidence, 95%? 95%, so we're way out here, 1.96. So I'm going to make this 33.49%. And down here's the lower one, 16.51%. What did we just find? What did we just find right here between these two numbers? Here's what we found. We can say with how much confidence? 95% confidence, based on the sample we did from that proportion of how many were left-handed out of the 100 people, that if we had the time to ask everybody in the world, well, I don't know, whatever the population is, but that sample, maybe that sample is just U.S. citizens. If we could ask every U.S. citizen if they're left-handed or right-handed, the proportion that are left-handed with 95% confidence is somewhere between 16.5% and 33.5%. We can say that with that much confidence and know it's true. That's what statistics does for us. It allows us to make that kind of an estimate. Now, don't get me wrong, 33.5% to 16.5% is a pretty wide gap. How, if you're a researcher and this were true research and you wanted to lower that gap, the easiest way to do it, increase your sample size. And that's what's going to lead us into Thursday's lecture. And Thursday's how we determine what sample size we need to get the kind of confidence we want. If this were really important, we wanted 99% confidence, our sample size is going to go from 100 to a whole bunch more than 100 to get to that 99% confidence. So that's what this is all about. Using samples to learn about a population that we can never ask everybody in the population, are you left or right-handed? Well, we would never be able to do that. It would take forever and tons of money. All right, let's do another one.
Is that how you want us to write our final answer?
Oh, I'm sorry, I forgot to ask you a question. What'd you say?
Is that how you want us to write our final answer?
I want the final answer. No, I want to see two calculations between the setup and the answers. But yeah, once you get to this point, I don't need this stuff. I just need you to tell me the lower limit and the upper limit. I don't need that. Show me what you added to 0.25 and subtracted. I'm not kidding. Let's do another one. I'm gonna do one of these. We'll do this one? No, let's do that one where we got to calculate. Oh no, we just did one we had to calculate. Okay, let's do this then. According to a survey, 44% of adults, so blah, blah, blah. Suppose the survey had 1,000 responses. There's our sample size. We're going to do 98% confidence interval. I don't think this is erasable with this board. This board's changed so much. See, it doesn't even erase. Hang on, let me get to a point here. We're gonna set this one up. Let's start with finding our z, because we know this is a proportion. It doesn't have a standard deviation. It's asking for a confidence interval. We know it's a proportion. It's given us a proportion. The proportion it's given us is 44%. We know that, so I can start this off with equals 0.44 plus and minus. Stop there. We're at our z. We decide we're going to use the norm SIMV equation. Tell me the number that goes in parentheses based on this question.
0.99.
Ooh, very good. You hear them? 0.99, because it says 98% confidence. How much significance is that? 2%. What's half of it? 1%. Add 1% to 98. 0.99 gives us a Z of? Buzz, I think you had it. No? Gives me a Z of? We're recording, you guys. I can't edit this long pause out for anything.
2.3.
2.33? Or is it 2.3? Give me a couple of digits.
26.
2.326?
Thank you, that's my line.
2.326. So here we go, plus and minus 2.326. Parentheses. I'm doing my giant square root so I don't forget that it goes over the whole thing. That's where a lot of mistakes get made. Now here we go. 0.44 times parentheses 1 minus 0.44 parentheses divided by sample size 1,000 parentheses. There it is. Wow. We had to solve this manually. That's how we do it. We gave the Z equation, or we gave the Excel equation to find Z. And now you have to show me at least 2 calculations, and then the upper and lower limit interval. Excuse me, not limit, interval. Here's the order again. Parentheses first. 1 minus 0.44 leaves you with 0.56, I think. 0.56 times 0.44 is blah, 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 divided by 1,000, then square root it, multiply it times 2.326, add and subtract that to 0.44. This is too easy, isn't it? Just my imagination, or is it really too easy? Now, in the other class, what we've learned in, well, when we get done with Thursday, what we learned in 3 weeks, I think they're learning in 2 weeks. So we spread it out a little bit. But everybody's still with us. We're not losing anybody yet. Everybody's pretty much understanding confidence intervals at this point. Don't get me wrong, I'm going to try to lose you on Thursday. All right, when we try to have the optimal number in our sample size. We have time for one more? We do. Okay. Oh, yes, yes, it's a major part of the quiz. The optimal sample size is huge. It's so important. Oh my gosh. Why don't we show us those? Okay, ready? A sample of 400, company finds that they have 20 successes. Manually construct a 90% confidence interval. Use Excel to find your Z or T. What's our proportion? Tell me how to calculate it. Which is right here, thank you. And what that equals, what is that? 10% would be 40, so that's 5%. 0.05, does that sound right? Okay, there's our proportion. Visualize this. I don't have room on the board to write. Do I? Do I have room on here? Let's do our norm S, I, and V. Just tell me, norm S, I, and V, what would be in the parentheses for this problem?
0.95.
0.95. Woo! 0.95, because it's 90% confidence, 10% significance, half of 10% is 5%, add it to 90, makes 0.95. So there's that part, 0.95. We enter that into Excel, we get, what's our Z?
1.645.
5, what's it?
644.
Okay, thank you. So you're saying the digit after that 4 was something we can round up to 5, right?
Yep.
All right, so there's our Z. Set this up, ready? 0.05 plus and minus, you said 1.645 parentheses. Help me out, square root the whole thing, very good. Square root the whole thing, what's on top? 0.05, very good. 0.05 times, I'm doing the asterisk, parentheses 1 minus 0.05 over. Tell me? 400. And parentheses. Wow, boom. We're all over this. Let's all get an A on this first quiz. It'll be a first time ever. And I tell you what, I don't know what. You see how much money I got before I make a commitment. Hang on. I'd buy it. How do we feel? We got this? It's okay? We're good to go? Let me look at my notes. Never! Oh, wait, I gotta stop this. I can't. This is only if you show up. You gotta show up for this stuff.